Hello, my name is Philmon, and today we'll be talking about some of the fault displacement terms. Some of the terms I'll be covering are the nest slip, separation, deep separation, heave, throw, and strike separation. The kind of faults that I'll be talking today are the faults that are present in the San Andreas fault system, that where the fault is cut through a pre-existing features and carry the two halves apart. By finding those two halves known as piercing points, we can determine how far they have been displaced. The kind of faults that I'll be talking are the one similar to the San Andreas fault system, where the faults are cut through a pre-existing features and carry the two halves apart. By finding these two halves known as piercing points, we can determine how far they have been displaced. Today we'll be talking about faults that are very alike to the one present at the San Andreas faulting system, where the San Andreas faulting system is literally cut off through a pre-existing features and carry the two halves apart. By finding those two halves known as piercing points, we can determine how far they have been displaced. From that data, we can start reconstruction. We can try to reconstruct the history of the faults over geological time. The more piercing points we have, and the better we can test models for tectonic plate motion. What is a fault? A fault basically is a brittle fracture along which a measurable displacement has occurred. To discuss about the stuff that I've been talking about, I'm gonna take some ice cream sandwiches and I'm gonna stack them one on top another, and I'm gonna make an oblique cut, and I'm gonna show you the following points. Here you go. Now we have an ice cream sandwich, and I'll try to make some cuts. And by making these cuts, I'm gonna show different kind of faulting in a different angle. For example, faults that are below the 30 degrees are called shallow. Faults are between the 30 to 60 degrees cutting are called moderate, and faults above the 60 degrees are steep faults. For example, okay, let's cut this ice cream. Okay, let's see. Okay, here we go. This one we might call it a moderate faulting, because I cut it almost 90 degrees. I cut it almost 45 degrees, and might be 45 to 50. So between 30 to 60 degrees, it's a moderate faulting. But if you come the other side and I try to make another faulting, let's see, almost close to 90 degrees. There you go. Okay. This is a very nice cut over here, and it's not exactly 90 degrees, but it's very close, might be 80 degrees, and it's called steep faulting. And to make a shallow that is below the 30 degrees, I'll try to make, even though the ice cream is melting, let's see. Okay, yeah, this might be a shallow faulting. Can you see it's the angle is less than 30 degrees, so it can be called shallow. Right. Now I have an ice cream sandwich. I made the cut almost 45 degrees, and this one is called footwall, and the other one is it's a hanging wall. And when we call disc-slip faults, we have two kind of disc-slip faults. We have normal faults and reverse faults. Normal faults is when the hanging wall goes downward. See, goes downward. This is called normal faulting. And when the hanging wall goes upward, is called reverse faulting. How can you see over here? And and the other side we call strike slip faulting. We have two kind of strike slip faulting. We have a dextral fault and sinistral fault. Distral fault is when the hanging wall, of course, moves to the right, and sinistral faulting is it's when the hanging wall moves to the left. How can you say? All right, and try to instead diverging these two the ice cream, so it's diverging, and okay, see, now has diverged, and this displacement between the two pieces of ice cream is called the net slip. And if I move again, this is a hanging wall, and I mean, this is a foot wall and this is a hanging wall. If I move the hanging wall, let's say to this side, and all this section over here is called strike slip component. How can you see it? It's a strike slip component, and if I move it up over here, and this component over here, the displacement is called the deep slip component. All right, now again we have this ice cream sandwich, and I make a faulting, and how I said, the separation is the distance between displaced parts of a marker horizon measured along a specified line. Of course, will vary depending upon the line chosen. A deep separation. A deep separation is the offset distance measured parallel to the deep of the fault. And we can have two kind of deep separation. We have the heave and the throw. The heave is the horizontal component of the deep separation. Meanwhile, the throw is a vertical component of the deep separation. All right. So I'm gonna show it to you over here. Let's see. I'm gonna put the hanging wall, putting downward. It's coming downward. See. Coming downwards, the hanging wall. Okay, see, so this point was over here before the faulting happened, and then this is the foot wall, and meanwhile the hanging wall went downward. So this distance taken horizontally between this point and this point is called the heave, and meanwhile the vertical distance between this point and this point coming vertically is called, of course, throw. And if I displace laterally to this, let's say lateral to this point, and the distance between this point and the other point, of course, is gonna be called the strike separation, and it's the strike separation is a offset measured parallel to the strike of the fault.